Let's look at another example very quickly just to get a feel for mesh analysis. Now, the mesh circuit that you see in front of you only has one power supply, which is 100 volts with 1, 2, 3, 4, 5 resistors that are connected to it. And we can start the process out as we did the last time by assuming currents that are flowing in all three of the meshes that are in this circuit. I1 will be the current through the power supply and through the 5 ohm and the 40 ohm resistor. I2 will be the current through the 20 ohm, the 10 ohm, and the 5 ohm resistor. And I3 will be the current through the 40 ohm, the 10 ohm, and the 15 ohm resistor. Once again, we're assuming that the current is flowing in a clockwise rotation. It may not be when we finish, and we'll see that from the analysis. However, it's a pretty good guess that that's the direction currents are going to flow, seeing how the power supply is connected the way it is. We will now use Kirchhoff's voltage law to sum up the voltage drops around the loop. In fact, we're going to do it for each loop, but we're going to start with loop number 1, which is current number 1. The KVL for I1, or the Kirchhoff's voltage law for I1, starting with the power supply of 100 volts, the voltage drop of the power supply is minus 100 because it is a voltage rise, actually. So in our equation, it is minus 100. And the voltage drop across the 5 ohm resistor is 5 times the current, which is I1 minus I2, because I2 is going against I1. It has to be subtracted. And the voltage drop across the 40 ohm resistor is 40 times I1 minus I3. And again, I3 is opposing I1, so it shows up as a minus sign when going around the loop number 1. And all of those voltage drops have to add to 0. Now we just proceed with mathematical manipulation, and the first step is to open up the brackets, which will give us minus 100 plus 5I1 minus 5I2 plus 40I1 minus 40I3 is all equal to 0. We can now collect the like terms, which are 45I1 minus 5I2 minus 40I3 is equal to 100, giving us our first equation. Looking at loop number 2 and current I2, the KVL for I2 is going to be starting with the resistor, the 20 ohm resistor, which gives us a voltage drop of 20 times I2. Going around the circuit, we come to resistor, the 10 ohm resistor, and the voltage drop across it is going to be given by 10 times I2 minus I3. And we finally come to the 5 ohm resistor again, but this time we're following I2. So the current in the 5 ohm resistor is going to be I2 minus I1, because I1 now opposes I2. And we're going to get the voltage drop by multiplying the resistance times that current, which will be 5 times the quantity I2 minus I1, all equal to 0. Now we will expand the brackets again. This time we'll get 20I2 plus 10I2 minus 10I3 plus 5I2 minus 5I1, all equal to 0. Collecting like terms, we're left with the equation minus 5I1 plus 35I2 minus 10I3 is equal to 0, which gives us our second equation. Looking at the third loop of our mesh, and more specifically I3, the KVL for I3, starting out with the 10 ohm resistor, The voltage drop across the 10 ohm resistor is given by 10 times I3 minus I2. Because we're following I3, it's plus I3, and I2 opposes I3 in the 10 ohm resistor. So the voltage drop is 10 times I3 minus I2, plus the voltage drop across the 15 ohm resistor, which only has I3 flowing in it, so it's 15 times I3. And finally, the 40 ohm resistor gives us a voltage drop of 40 times I3 minus I1, because I1 is flowing in the opposite direction to I3, and because we're following I3, it's I3 minus I1. All of those voltage drops add up to 0. Next step, open up the brackets, which gives us 10I3 minus 10I2 plus 15I3 plus 40I3 minus 40I1 equal to 0. Collecting like terms, we're left with the equation minus 40I1 minus 10I2 plus 65I3, all equaling 0. That leaves us with the matrix equations that you see there highlighted in red. And now we can solve those three equations for three unknowns, and we can use whatever method we want to use. But after we do that solution, we will find that it generates I1 equal to 6 amps, I2 is equal to 2 amps, and I3 is equal to 4 amps. We now have all of the information we need to analyze this circuit. However, we'll take it another step further, and because the current flowing in the 5 ohm resistor was given by I1 minus I2, and I1 is 6 amps and I2 is 2 amps, so I1 minus I2 is 4 amps. The current flowing in the 40 ohm resistor is given by I1 minus I3, which is 6 minus 4, which gives us 2 amps, which is the current flowing in the 40 ohm resistor. And the current flowing in the 10 ohm resistor is given by I3 minus I2, which is 2 amps, because I3 is 4 and I2 is 2. I3 minus I2, or 4 minus 2, is equal to 2. Stay tuned to this site, as I'll be diving into more information from my electrical courses. In the meantime, take advantage of the availability of my 50-page electrical power crib sheets by simply filling out the information when you go to this website, https://bit.ly/47 uppercase y, uppercase b, 3 lowercase v, and lowercase h. You can also directly access my StanStore courses at this website, https://lowercase stan.store/uppercase G, uppercase V, uppercase B.